big day, we're really excited. But when Eagle was thinking about starting or joining the AP pre-calculus bandwagon, I went to a conference to get trained, a training, and it was run by, I think probably the guru of AP pre-calculus. This guy is Mr. Passwater, and he is phenomenal. If you will see, he shared with us all of his materials, and he continues to share. So you will see down here, I try to credit him with everything. He also has, I don't know that he videos every lesson, he videos some things, and so if you just Google Brian Passwater, you might be able to pull up some videos that if I'm not explaining it right or if you have confusion, that might be able to help you. He is absolutely magnificent. And when we get to Unit 3, I have the most awesome story to tell you. So I'll remember, I'm sure, but you might remind me in February or whenever we get there. He's amazing. But anyway, I want to give him credit. Almost everything you get from me that's typed is either from him or from Calcmetic. If it's handwritten, it's my stuff, but I use a lot of his stuff because it's so good. So here we go. Topic 1.1, changing tandem. That's rate of change, nothing to be scared about. It's basically soil. All right, here we go. Can you fill in the blanks in that first sentence? You've heard this before a million times. What is it? A function. A function is a mathematical relation that maps a set of inputs onto a set of outputs, so that each input is mapped to exactly one output. Yep, you know that. Now, he inserts a little caveat here about the vertical line test. For now, in Unit 1, for now, the vertical line test is A-OK. What is that test again, you remember? You have some shape, you do vertical lines, and it can only hit the curve once, right? Now, that works great as long as you are in the Cartesian coordinate plane, X's and Y's. As soon as we leave that, then we still have functions, but the vertical line test isn't so useful then. So just kind of put that in the back of your mind. For now, it's great. What do we call the inputs? The relation is inputs and outputs. What do we, a function, relation and a function, inputs and outputs. What do we call the inputs? The domain. And the domain consists of the, well, you think X's, and that's okay, right now it's fine to think about X's, but they're called the independent variable. They are the independent variable. Whereas the outputs are the range, and they are the dependent variables. And that vocabulary shouldn't be unusual or anything odd to you, because think when you were a little kid and your teacher said, okay, let's build a table of values, because we're going to graph this or something. What did she tell you to do? First, you just what? Pick some X's, and then you plug them in and get your Y's. So don't these depend on these? Yeah. So that's why these are the independents, and these are the dependents. Okay, so now we're going to sketch the function f that halves the input values and then adds 1. All right, so what do you think? Okay, so then says, let's write an equation. That should be one option for sure. Give me a number, I'm going to take half of it and add 1. Would you agree with that? So I'm going to plot that now on the domain from -4 to 4. So if I put in -4, I get -1. And if I put in 4, I get 3. And if I put in 0, I get 1. Would you agree with that because this function takes any x value in your domain, halves it, and adds 1. Beautiful. All right, you do B. B is not a verbal description. B is just a table of values. What do you think that one looks like? You know what yours looks like? Is that okay? Now, did you connect those dots? I think you have to be careful about that, because this one I could absolutely connect them, because my function said any x you give me, any x, I'm going to divide by 2 and add 1 to it, right? Any x. Does this one have any kind of general rule that way? For example, if I connected these, do I have any way of knowing from the chart what happens at 1? No way at all. So these aren't going to be connected. These are just going to be a series of dots. Right? At the bottom of the page, a summary or another way of writing what was on that blue sheet we talked about last time. Please keep straight. It's so hard, it gets so confusing, but keep practicing. If the function is increasing or decreasing, we're talking about its slope. If the rate of change is increasing or decreasing, we're talking about concavity. Alright, so it gets confusing for sure. But that's it for today. We'll pick up here tomorrow and keep plowing along in Unit 1. And you can gather up your things